Hello friends, welcome back to our channel Mirror Neuron, which means watch and learn. And we are currently studying about machine learning algorithms. And our today's focus is on multivariate ordinary least square. And previously we have seen the single dimension OLS, and also we have calculated the loss function of single variable OLS. Today we are going to look into the multivariate OLS as well as the solution to the multivariate loss function. Okay, now before we jump start, we will look into few basic notation which will help us in the derivation. So here we have couple of records which can be, these are the individual records, and this will be represented by I. So basically a number of records are 1, 2, 3 and so on till n. Okay, so this will be the basic notation. And we have number of features here. In this example we have 3 features, which are TV, radio and newspaper, but in other data and other projects we can have more features, and that will be represented by xi. Okay, and if we have to look into the first record here, okay, so xi can be is a vector, now is a row vector if you see here. So this portion here, okay, so your xi will be basically xi1, xi2 and xi3. Okay, and this is nothing but, if we also have to write the data part, so it will be 230.1, 37.8 and 69.2. so this is just a way of representing the data, because end of the day computer has to solve this. All right, and if we have more features, so this will be extended till xik. So for example we have k features in if you are trying to generalize this, right? And then we have a third notation for the yi are basically the single values here. Okay, this is the feature, so yi, and for the very first record it is 22.1, so that will be equal to y0, that means the first record, and so on. We'll have 10.4 for y1 and so on. Okay, all right, so these are the basic notations. Now if we have to look into the entire data set which is here, if we have to look into this entire features data, that we represent by something called as data matrix, which you have already seen in our previous videos, but still I'm trying to repeat it if somebody has just started from this video onwards, right? And this can be represented by x11, x12 and so on. So I have, say, k features. In this example it would be only up till x13, right? And if I have to extend it, then it will be xn1, because we have n records, n number of records, then it will be xn2, so on till xnk. That means because we have k features. Okay, all right, so this is known as data matrix, and typically will represent this entire big matrix with a capital X. Again, something not very not confusing. We have already seen this so many times. We are just representing a collection of features with a big matrix represented by capital X. Okay, so in case of single variable OLS, what we have seen is the predicted value, right, with the I hat typically is represented by m of x plus b, because we had only single variable, which is the x here, right? So we had the m as the slope and we have b as the intercept. But in case of multivariable, this can be extended and it would look something like this. So basically you again have an intercept term m0, but then we'll have multiple coefficients or slopes, right? So we have m1 xi1 plus m2 xi2 plus so on, right? And we can write it as mk xik. So this will be for the one of the record, and we're trying to just generalize that. Now if you see here, this can be represented like a dot product between two vectors, which is xi, right, is can be a vector dot product with the coefficients of all the slopes. So this can be represented this way. And you must have also seen in many articles that it looks something with a beta as well. So somebody represents this coefficient with beta, somebody does it with m, and somebody also would do it with omega. Right? It totally depends on how you want to represent, but the main idea is that it looks like a dot product, right? So basically a column vector multiplied with a row vector. Okay, and this in vector notation, if I take all the values of this yi, would also look the capital X now, because we are taking the entire data set, not a single record. So your capital X times capital M. So basically it's a dot product. And sometimes you can also see it this way, beta. Beta is more common, but nonetheless, they both mean the same thing, and it's a dot product. Okay. All right. So now that we have covered the notation and how my model would look like in a multivariable scenario, let's define the loss function for this case.